Good morning, everyone. We're going to progress with new material, and we're going to start with carboxylic acids. And I hope we have audio and everything. It looks good. And here we are. Look at chapter 17. 17. Carboxylic acids. And we have to remember that a carboxylic acid contains a carbonyl, and the carbonyl also possesses a hydroxyl. These are resonating functional group with the lone pair on the oxygen capable of resonating towards the carbonyl and the pi breaking and forming an oxide over here. This resonance form is not as stable by a long shot. It has two charges, and that's that. We have 120-degree angles around an sp2 hybridized carbon, and in this resonance form, 109.5 degrees in this sp3 hybridized oxygen. Sigma, sigma, lone pair, that's 4 items, sigma sp3. Okay, little bonding review there. Haven't seen that in a while. What we're going to do now is review reactions we've seen that already make carboxylic acids. I restricted it to the synthetic creation of carboxylic acids. There's other methods such as ozonolysis that will generate carboxylic acids under oxidative conditions that we are not going to deal with. But you always have to remember this reaction: a primary alcohol, when treated with chromic acid, formed either by reacting CrO3 or K2Cr2O7 with aqueous sulfuric acid. Chromic acid will oxidize a primary alcohol to first an aldehyde, but the reaction cannot stop there. The aldehyde is an intermediate in this reaction, which will then further react under the same exact conditions. So if you started with an aldehyde, as we learned on our problem set, you will also oxidize it to a carboxylic acid. So primary alcohols undergo 2 oxidations to make carboxylic acid. We're replacing each CH bond here with a bond from C to O. There's 2 of them now. You took 2 bonds to less electronegative hydrogen and replaced them with 2 bonds to more electronegative oxygen. That is the organic chemistry definition of oxidation. The electrons had to move further away. When the carbon replaced bonds to less electronegative H, where the electrons were closer to carbon, with bonds to more electronegative O, where the electrons are farther from carbon. The electrons moved farther away. So that is oxidation. And this is probably the most common way to do it. If you took a primary alcohol and reacted it with the other form of chromium, PCC, pyridinium chlorochromate, some of you read outside of the textbook, and you probably saw pyridinium dichromate, does the same thing. You can oxidize a primary alcohol to an aldehyde, but that does not belong in this chapter. We already looked at that in chapter 16. We're going to look at Grignards and organolithiums reacting with not aldehydes or ketones, but rather with carbon dioxide. Carbon dioxide has a very positively charged carbon. It's not a cation, but because of the 4 bonds to more electronegative oxygen, it is a very positive carbon that can be attacked by a anionic nucleophile such as methyl lithium. Methyl minus would be the active ingredient in methyl lithium, and it will attack much like we saw in chapter 16, where you attack the carbonyl and generate an oxide, and the oxide protonates in step 2 to make, yes, a carboxylic acid. This is a useful way to make a carboxylic acid that has one more carbon than your nucleophile. Here is the nucleophile. Here is the one more carbon. And there's the nucleophile carbon right there. It has one more carbon and it's a carboxylic acid. Nothing more needs to be said about this review and this slightly new item. I wouldn't call that entirely new. I don't think this surprised anybody here. Before we move on to the next part, I see that it's nomenclature, everybody's favorite part. Two main naming systems for naming carboxylic acids. The International Union of Pure and Applied Chemists say that you change the name of methane, which would be CH4, to methanoic acid. So we have the ending becoming oic acid in every example. Oh yeah. Probably just faster to underline it each time. Maybe it's not. Isn't it fun watching me play with this thing as it thwarts my intentions? And does this follow the pattern? It follows the pattern here where the common name is actually much better than the UPAC name. UPAC says if a carboxylic acid is sticking off of a ring, name the ring and change the end to carboxylic acid. I would like to remind you that that is the same exercise as this for the, oops, let's not do an octet violation on screen. We prefer to call it benzaldehyde, but following the UPAC rules, I just want to remind you, you've seen something similar to naming the ring and then saying there's an aldehyde attached. The ring is called benzene. And when you have a group that's an aldehyde, you say carbaldehyde as a separate word. And we had that on our last test. So the same system works for carboxylic acids. Just use these two new words, which you see down in our worked examples down here. I will let you look over those selected examples on your own, and we'll do our own selected examples. Let's do one that has a ketone and a carboxylic acid and a simple double bond with geometry. So we have to ask ourselves this question first. What is the most important functional group in this molecule? And here's your guideline for the importance of functional groups in nomenclature, which we finally hit the pinnacle. The top of the heap, carboxylic acids and their derivatives. Yeah, my B didn't get a top there. And chapter 17 is derivatives of carboxylic acids. And I would like to point out that these always have 3 bonds to more electronegative oxygen. So when I ask you the question in chapter 18, why these molecules belong in this chapter called carboxylic acid derivatives, I want somebody to say because they have 3 bonds to a more electronegative atom on the same carbon. And I will see who remembered this statement. Aldehydes and ketones have only 2 bonds to oxygen. And alcohols have only one bond to oxygen. So in terms of oxygen-containing species, which are the highest priorities in organic nomenclature, these are the top 3. So that answers the question. We have carbon 1 with the carboxylic acid. It's the most important functional group. We're going to have to try to remember a name for a carbonyl when it's not allowed to be called a ketone. And did you remember? Of course you did. It's oxo. So there's an oxo group on carbon 5. And the double bond in this alkene, quick double bond EZ review. Remember, EZ is the most general method for doing geometry. It says put on those missing H's and assign priorities 2 and 1 and 2 and 1, and the ones are on opposite sides, so it's E. 5 oxo, 6 carbon hex. What does this say about, say, 4 carbons? You don't end it with hexane. In fact, we won't even end it with AN. We'll end it with EN. 3EN. But don't draw the E. Everything that was an E at the end, like butane, becomes butanoic acid, becomes hexenoic acid. And that is a good 2-point nomenclature question. And let's do another one. Let's do a ring action. And just to make sure you know there's a carbon there, I'll put a stereocenter. And if I leave it like that, we don't have a stereocenter. Let's throw double bond in here. Put another carboxylic acid on it. So that'd be a nice 3-point question. It's got a stereocenter and a double bond with geometry. The double bond with geometry, let's treat it more like a test question here. In fact, we need original versions of these before they were doctored. Hey, I'm having that issue today, aren't I? Move these down. And we need this. Clearly, we also need that. There we go. Looks all right. And then hopefully I drew this all at the same time. No. Good thing I caught it before we started doctoring it. We need an original question. There we go. So let's doctor it up. And we got the double bond with geometry. Got an H here. That's the 2. There's the 1. There's the 2. C with bonds to O. We're on a very E day today, aren't we? E. What's the most important thing here? Okay, there's options now. The naming system for putting carboxylic acid off of a ring says name the ring first, then add the carboxylic acid, in this case, carboxylic acids, to the end of the name. Now, if you follow those sentences strictly, then you can think of it as naming it without the carboxylic acids first. So let's pretend they don't exist and do it that way. And if you start panicking, then I'm going to say, oh, we can also say, I acknowledge carboxylic acids are the most important functional group, and that will also be an acceptable name. So I have some flexibility here that should make you more comfortable. So what's going to happen here is I'm going to name the first way around as if the carboxylic acids aren't there. So I want my double bonds with the lowest possible number. So 1. Two choices being 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 7, 8. And yes, we're pretending the carboxylic acids aren't there, but we can't also pretend the CHI2 isn't there. That first way around put a group on 5. Remember, this is the system that you're naming the ring as if the carboxylic acids aren't there. So here we have a group on carbon 5 called a diiodomethyl. Diiodomethyl. And the ring size is 10. Oop, deck. There's a double bond. Deck. If this just cyclodecene, it's understood the double bond is between carbons 1 and 2. And you made that clear when you started here. And you're getting groups here and here. And now you've got to say 2,5-dicarboxylic acid. Separate words. 2, 5. There's no dash in front. And yes, I haven't acknowledged the stereo center. And I will even put in here, I hope you don't write this on an exam, that you need a space right here. Okay. And it's not just E, it's also got a stereo center. And the double bond has E geometry on 1. Stereo center to be determined in blue here. C with bonds to I is 1. C with 3 bonds to O is 2. Just 1 bond to O would have been sufficient. This one hits, the CH2 hits stuff before this CH2. And double switches in order. We are experts at the double switch. 4 just switched with 1. And 3 switched with 2. And that is an R stereo center on 5. And as promised, I would accept another name. We're going to have to do a little more editing than I thought, which is okay. Over here, if you're saying the carboxylic acids are more important, and your numbers are going to change to orange. Oh, that eraser is a little chunky. Okay, in orange, we see you're saying the carboxylic acids are the most important. So I want them on the lowest possible numbers. And then I want the double bond on the lowest possible number. So clearly, if I go here, then my double bond goes between, if this is 1, 1, 2, 3, it goes between 4 and 5. Orange is a little too close to red. Some screens might not be able to distinguish those. Light pink. 4. Okay, so we have a double bond on 4. Tell me that. And the group is on 5 and 1. Sorry, carboxylic acids on, I got my numbers, pink, 1 and 4. My double bond is still R, but now my stereo center is still R, and it's on 5. Okay, now if you think you have an alternate numbering system, I don't think, even if it was wrong, that going in more depth on this problem for 0.25 more points is worth it. So if you're comfortable with either of these ways, then you are comfortable with the way I'm going to grade this question. Stray mark here. Space. Oh, I erased something, didn't I? The dicarboxylic acids were on 1 and 4. And 1,4-diiodo. Yes, thank you for not interrupting. The diiodomethyl is only on 1. Your patience is impressive. Thank you. And the carboxylic acids are on 1 and 4. See, even a veteran instructor, he's tempted when he sees di to have two numbers in front. That's only if there's two groups that are the same. There's a single group called a diiodomethyl here. Then my next example is going to be a preview for what comes up on the next screen. Why I'd rather see there, I don't know. But let's have a couple copies of that. We'll do a UPAC name, and then I'll give you the common name, and then the most common name. Clearly, we have 2 carboxylic acids in a 4-carbon chain. It's a dicarboxylic acid. So, a little awkward here. Don't think we've seen the alkane name reinstated before. I think the people at UPAC argued that butandioic acid just didn't sound nice, so they put the E back. I think that's their logic. If you leave the E out on a test, then I will not be upset at all. And there's a group on 2 with an OH, and that has to be called a hydroxy because you're not allowed to call this molecule an alcohol. 2-hydroxy butane dioic acid with a stereocenter that is, let's do it. A direct bond to O is better than a bond to C. A C with bonds to O is better than a C with no bonds to O. And for trusty H in this case. And this is also our very righteous day today. You can also call this, and this might not make you happy, but R2-hydroxy and succinic acid. What? How are we supposed to know that? Okay, wait till the next page. You can also call it, here. You're gonna like this one. Sounds like a nice Arabic name. R-malic acid. You don't have to memorize that one, okay? There's 4 carboxylic acids that start with mal, and they're all different. Malonic, maleic, malic. There's a mandelic too, but that's not a MAL. See those in lab. And yes, dicarboxylic acids are very common in organic chemistry, and their names are used to name many biological molecules. So we have to learn this page. We have to know all of them, except the bottom 3, which it says you don't have to know all of these. And it's got a memory trick. Now, the number one thing that messes students up is The memory trick doesn't start with one carbon because this is a dicarboxylic acid handout. I wanted the right number of C's. You start with the number 2. You can't have a 2 carboxylic acid molecule with 1 carbon. So before you start doing the little memory trick, you start with 2 fingers in the air and you go, oh my, such good apple pie. And you've got 7 fingers up, you up to pimelic acid. So it's a nice little memory trick that almost every biochemist and organic chemist knows. Oh my, such good apple pie. That's cute. That's great. But you need to know what each letter stands for. Oxalic, malonic, succinic, glutaric, adipic, and pimelic. And as promised, there's another one of the acids that starts with MAL. Okay? And a lot of biological molecules names are derived from these. And because you have an instructor that warned you ahead of time, you are going to take this as an invitation to get ready for your future courses like biochemistry and learn these, so that when a biochemist asks you to draw alpha keto glutaric acid from the Krebs cycle, you're going to get your hands out, aren't you? Start with 2. You got to get to good, right? G. Oh my, such good. That's 5. You're going to draw 5 carbon dicarboxylic acid before you even start. 1, 2, 3. And you guys know what alpha means. You knew that from test 1. There's a ketone on the alpha position. There. Krebs cycle intermediate. And there it is up there at the top of the screen. You could also have glutamine or glutamic acid. It's got glut in it too. And I'll just tell you, that's an amino acid. And how you want to do amino acids, a way you can remember their natural stereochemistry is that they all have this first stereocenter on the left. And they have an amino group on the alpha position. So right here, this covers all the amino acids. The only variables down here in glutamic. Got a little carried away here. We only need 1 stereocenter, so we're up to 2 carbons, 3 carbons if you count the stick at the end. And then you can go 4 here. Make sure you got 4. Oh, glut is 5. I did succin. I'm not going to erase it. I'm going to move it. Meanie. Okay. I have a different amino acid, so it wasn't worth entirely erasing. And we have the amino group on the left. Some of you know this is not an appropriate way to draw amines and carboxylic acids in biochemistry, and that's coming up later today anyway. And I'll just say this, aspartic acid is, let's do it this way. Hello. Succamic. I wanted to follow the same pattern. These are amino acids. Glutamic and succamic. Nobody calls it succamic acid. You're going to call it aspartic acid. They should have called it succamic acid to make your life easier later. And I'm going to fix my glutamic acid because, as you know, it has 5 carbons, not 4. Just extend it down 1 more. And that is a good conclusion of my acids to die for table here in the book. Oh my, such good apple pie. And you can go sweet as sugar if you want to go to the next 3, but I'm not going to make you responsible for that. This is a good stopping point for us. And I will see you in a little over 5 minutes.